So this is a new function that we just call it a speed guard. So we can look at the context a little later, so what it could be used for. But basically it's just going to check that we get pulses into a system, some pulses that indicates that something is rotating. So here too, now we are way down here, so we should move over here. And what we have here is the speed guard with a program and an instant data block. This has to be a function block 2. And then I'm going to move back here. And that's function block programming again. We get to know function block and so on. Final state machine, question mark, you could use. Retain parameters and program timing. We need 2 timers for this one. So how to make 2 timers with our system. The speed guard we have. Enable input and X where the function block checks if the pulses input X if X is true. So this enable could be that there's a motor running so that you should check that our pulses, because if the motor is not enabled, there wouldn't be any pulses. So makes no sense to report an error. So there should be a parameter that is the maximum load time between pulses. So what time do we measure? If we don't get pulses within this interval, then we say, okay, there are no pulses and there's a fault. And then you should have an alarm delay. Specified times it takes for fault output to be set to true after pulses has stopped. Time after delay too. And this is here just so we need 2 timers. Time after delay for this one. Yeah, well, no, we can use the same timer. We should output YGH to indicate verified pulses. This should be true as long as we have pulses. So that one shouldn't pulse. It should be set to true. And then output I1, which stores the actual spacing between the pulses. So when this is running, this has to do, we can look at it, and so we know what should this parameter be in our system when we are testing it. And here is where you need an additional timer to measure this. Have 2 digital inputs, outputs, warning and fault. Warning indicating pulses have stopped, and YF indicating now they have stopped for too long. This is what it says. And then again, test the function, calling in program main, making an instance data block, and so on. Yes. So here's a suggestion. Enable, we talked about X, reset the fault. I don't think we talked about this. Should be, let's say up here is an RX input somewhere that you save the fault. Yeah, it says here reset fault input. And these are the parameters. Retain again. So if we switch off the power to PLC and with power returns, it keeps the value here. We don't have any defaults value here because we don't know anything about this. This is the verified pulse train. This is the actual pulse spacing, time value. The YF, Boolean, pulse train fault, warning, and then we also can output the state, because this can be a final state machine and we are outputting the state too. So there's a user that is check what state is this one in. And then we have statics. Here is for edge detection, the SPX and TBX. We need to know if it's restarted, go to initial state. Timing system, which are arrays here because we are using 2 timers. And then also for the final state machine, we have idle. So it's doing nothing there. It's not enabled. We have the pulses. There's no pulses and there's fault. So the pulses, and then the pulses stop because we don't get the pulses. We have the fault. The no pulses will wait, and then we get fault. And then we have an index for the timers. We have the pulse spacing timer and our fault timer. We have 2 timers. And this maximum timer values that we use to wrap our program. Yeah. So 2 timers, fault timer, and pulse spaces. We could use 0 and 1, but just name them. So you know this is the pulse timer and this is the fault timer that we're working on. And then we make arrays here when we have 2 timers. Every 3 timers, this array is 3 and more timers you need. But usually you don't, using this timing system in a function block, you usually don't need a lot of timers. Here is again some pseudocode. So again, the way we work, Preset temporary, check if the PLC has been restarted or if it's not enabled. So it's idle state, we go to initial timing system, positive edges on the input, measure pull spacing, reset error if the reset input is true, handle fault timer, and so on. And here's the case. Set pull spacing memory to 0, function is enabled, and we assume pulses, and reset fault timing. In pulses, positive edge, reset fault timing system, just reinitialize this. And then set pull spacing memory to the measure pull spacing. So on each pulse timing. So too high, means there's a timeout here. Then we go to no pulses, fault timing system reset, no pulses. Positive edges, we go back to pulses again because we get new, so we don't set the error output, but maybe you should set warning output, and so on. Did we have a warning output? Yes. Pulse trend warning. Yeah. Pulses, no pulse detect with an alarm, fault memory is true, status fault, reset fault timing system fault. Pulse spacing memory, a positive edge detected, then we have pulses again, and so on. The YGH output, the high output is status we are in the pulsar state, so we are all okay. Pulse spacing, a pulse spacing timer memory that we have set somewhere here. And fault is fault memory, and this should be warning. It should say warning here, set warning is state equals to no pulses, and then we output the program state. In context, we have a motor, a transport, a band. So if the band breaks, the motor stops. And here is where we detect the pulses. So it could be an inductive detector and some metal on this roller here too. Maybe it's 50-50, so we should have 50% duty cycle. So which is the input here, and the external enable is from a motor controller that we have. Say, okay, the motor should run, then we enable our SpeedGuard, and your motor just gets the true-false feedback that the motor controller needs. You kind of fool the motor controller so it gets a true-false feedback. It is running with these pulses. So you've got a band breakage here or something, the motor stops, this stuff is going to stop, and there is an error on the motor controller. What we should do here, maybe we should stop a transport further upstream here or whatever on this fault. So this motor controller would have a fault output indicating that there are no verified pulses. So that was this function, call it a speed guard, so a guard function for speed on a transport or whatever. Something that should rotate and generate pulses on an inductive detector or something. And there was some pseudocode here too. There was a small error. It should be a warning. I'm going to fix that in the assignment. So I think pretty much that was it. There was a suggestion for the finite state machine. It doesn't have to be a finite state machine, but it's easier to program a finite state machine or make a robust program for this function when you program a finite state machine.